Example 3. If y is distributed normally with a mean of 20 and a variance of 9, find the value of b such the probability of y being greater than b is equal to 0.0668. Now this question is different in a number of ways. Firstly, they have given us the probability, but they haven't given us the value that we're less than or greater than 2. This value b is what we're going to need to find. So we need to work backwards to what we've done previously. The other thing that makes it unusual is that they have given us the variance defined as an exact number, not as the square of something. Now, this is far less useful to us. We are far more likely to make the mistake here of assuming 9 is the standard deviation. It isn't, it's the variance. So I'm going to rewrite this right at the beginning and say y is distributed normally, the mean of 20, but a variance of 3 squared, just to prompt me later on that it's 3 that's the standard deviation, not 9. Draw a picture. So we know the mean is 20 and the standard deviation is 3. And I know I'm above a certain value. I don't know what that value is. It's somewhere along this x-axis, or I suppose y-axis in this question. But I know greater than that value, I have an area of 0.0668. Now greater than 20, which is the mean, will be half the distribution, so 0.5. I'm a lot smaller than 0.5, so I must be much more up towards this high end. So I'm going to mark my value of b there and say that that area there is 0.0668. i.e. that's already giving me a bit of a clue that my value of b needs to be above 20 when I get to the end. So what were we told? That the probability of y being greater than b is 0.0668. Just like with forward probability calculations, I can't work with greater thans, I have to work with less thans. So we're going to turn this round. So 1 minus the probability that y is less than b will be 0.0668. Rearranging that tells me that the probability of y being less than b is 0.9332. The important thing is that these two numbers add up to 1. We then need to convert to our standard normal in exactly the same way, but we're going to have some algebra involved this time. So the probability of z being less than, now it's b minus the mean, which is 20, divided by the standard deviation 3. I can't work this value out at the moment. It's just going to have to stay like that as algebra. I do, however, know that that probability is 0.9332. So I'm going to use my graphical calculator, stat mode, distributions, normal, but this time, rather than using NCD, which is if we're actually working out a probability, if I want a Z value, I actually need to use inverse normal, where we're given a probability and I want to find the Z value. Note, we still don't use this, we will never use this. So inverse normal. Check it's set up correctly, so my sigma needs to be 1 for my standard normal and my mu should be set to 0. But the area is our probability, so 0.9332. Scroll to the bottom. Now you can't get it to draw a graph in this mode, but it will work out that value for you. So my Z value that corresponds to that probability is 1.500. Hence, b minus the 20 divided by 3 must be 1.500. So I'm going to times up by the 3 and then add on the 20, which gives me a b value of 24.5. Note that does agree with what we said, that b needs to be above 20. So that's my answer.